first of all, thanks. I'm really glad to be here. It's my first time at ContainerDays, and it's an amazing event. So thank you so much for everything, whatever. So, and also thank you to attending my talk that is named Kubernetes Pod Deep Dive. And I'd like just to introduce myself. My name is Dario Tranchitella. And first of all, as usual, I say in the conference, I am first of all a father of two. I got my little cluster in HA. And after that, I'm also a developer. And since few years, also a DevOps. And I like to play with Golang, and I was former drummer, and I'm really addicted to music. And for example, right now, my favorite artist is Devin Townsend, and I really love him. By the way, right now, I'm a cloud DevOps engineer in the Namecheap cloud team. And what we are doing in Namecheap? Well, really cool stuff. I'm developing the middleware API level of our cloud infrastructure, based obviously on Kubernetes. I'm extending also Kubernetes using CRDS, and I'm also developing microservices with Python. But this talk is not about what I'm doing in Namecheap. This talk, as I said before, it's about Pod. And also, a little recap why I proposed this talk. Well, before joining Namecheap, I was a cloud consultant, and I used to go to customers on site and solve problems. And I remember that a few years ago, I started using OpenShift. OpenShift is a Kubernetes distribution realized by Red Hat. And I started using Pod, also because it was my first time with Kubernetes. I used it before Mesosphere DCOS. Who know what is Mesosphere DCOS? Yeah, it's a huge monster, by the way. And I started using the Pod. And my first question was, what exactly is a pod? And I didn't find any reasonable solution to this, no answer to this question. So I decided to do my talk after some examination. And this talk is not to be a copy-pasted quote. I will try to do all my demo on this stage. I know I'm using a quote right now, but it's just a joke. Well, let's talk about Kubernetes, by the way. What is a pod? No one is saying what is a pod, and you just need to read the first manual, by the way. What I say is that because when we would like to get information regarding Kubernetes, there is the documentation. The documentation is awesome, but it misses a lot of practical stuff. And I realized also this little meme. I'm sorry, but if I will describe myself with an emoji, I will be a troll face. I like to create a lot of jokes. And this is me, the first time when I saw a pod, and exactly, I was looking into a running container, and I said, is this a pod? Well, exactly not. Then I also Googled to try to find a solution, a description of what is a pod, but I found this definition is not so really comfortable to code of conduct, so don't worry, I'm going to skip it. So, as I said before, the description provided by the Kubernetes documentation is awesome, because we know that a pod is a group of one or more containers. That could be Docker, Rocket, or whatever, with shared storage network and a specification for how to run the containers. A pod's content are always collocated and co-scheduled and run in a shared context. A pod models an application-specific logical host. It contains one and more blah, 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 blah. Okay, I think that the documentation is awesome. I already said that also because they chosen the right words to describe exactly what is a pod. But I'm a developer. I want to see the code, and this is the right definition and the right implementation of a pod. Obviously, we are not going to spin up pod in this way. We are going to use demo sets, deployment, or are you using OpenShift deployment configuration, or whatever you want. But in the end, this is the real definition of a pod. Obviously, right now, I avoided to insert all the specifications, so you can see just the containers, the name, some resources, and so on. So, right now, we answered our question, is this a pod? Well, not exactly. Also because we just read that a pod is made of several containers. So, what is a container? Do you know what is a container? Come on. Do you know what is a container? So, yeah, a container is made of just, long story, really short, is made of namespaces, cgroups, and a copy-on-write file system. I remember that I approached containers thanks to a nice talk hosted in ContainerDays 2016 in Italy by Giulio De Donato. I'm sorry, it's in Italian, but you can switch to subtitles on YouTube or Vimeo, by the way. It's really, really good. By the way, I started also to figure out how containers are scheduled on a Kubernetes pod. And I noticed that there are several running containers. And as you can see, the black guy, that's my expression when I first ran Docker PS inside a Kubernetes node. And I asked myself, what the heck is the post container? I mean, we see Kubernetes pod name, and we see also some post container. So it's something that is really weird. I don't know if you already know what is a post container and what's the purpose of the post container, but it's pretty important, and I decided to start my investigation. You know, I'm a developer. I like to start from a high-level abstraction to get deeper in the low-level implementation. In fact, I started with Mesos for DCOS, then I went to OpenShift, then Kubernetes Vanilla, and right now I'm near the low level, probably. I don't know. I hope that. We have always to learn something. By the way, what's the post container? I searched on Google, and I found this really, really nice video. I hope that we can skip the first seconds. And this looks the pause pod. Yeah? That will be really nice in an office. By the way, I'm working from home remotely, so I don't even need it. And yeah, this is the post pod, but we were talking about the post container. In fact, a guy on Twitter said, sorry to be pedantic, but it's not a pod, it's a container, as you saw before, right? Sorry, a lot of jokes. So let's show some code. The post container actually is written in C. Who loves C? Wow. Glad to see so many hands. So this is the implementation directly from GitHub. As you can see, we got several functions. And we got function main, and after that, several SIG actions. Who knows what is a SIG action? Nobody knows that? Yeah, quite. I'm going to try to describe that. I'm sorry if I'm going to make some mistakes, but I'm just trying to give a quick overview. SIG action is just a way to handle signals that a program receives, okay? In fact, let's see. the sig action, examine and change a signal action, returns 0 on success, a negative number on error. As you can see here, we are doing this stuff. If the result of the sig action is negative, return 1, return 2, and so on. By the way, as you can see, we are using several signals. We are the sig interrupt, sig term, and sig child. As you can see, these are the numbers of the signals. Sig int is interrupt from keyboard, and sig term is 15, termination signal. And a nice quote, what about the 42 that you can see here? What is 42? Do you know what is 42? Yeah, don't panic, guys. Yeah, I'm not so sure it's a real exit code, but probably it's a quite joke. And since I love to say jokes, I thought that it could be a nice idea to show it here. So, what exactly is doing a post container? When we spin up a pod, a container, just with a pause inside, start, and let's wait. It's just pausing. It's waiting something. So it means that we are going to do something else with the post container. And just for the sake of clarity, I'm going also to show how is the post container is made of on OpenShift. OpenShift, the Kubernetes provided by Red Hat. And just a little notice, I'm showing the code before the release number 4 of OpenShift because I used to work with OpenShift 3.4, I don't remember so well. So I just discovered that the version 4 has been released and some stuff has been changed. By the way, this is even better because it's written in Go, and I really love Go, and let's take a look. It's just 15 rows of code, line of codes. And what is doing this pause application? We just create a channel that is going to accept a signal item of one. It's going to accept just a single signal. And let's wait the receive of the signal. We are going to accept the interrupt, the kill, and the sig term. So it's quite similar to this one. Just a little notice. We are not handling at OpenShift level the sig child. Sig child is when we are also setting forks to our process. So I have no idea why there are no implementation of children's. By the way, we are just focused on single items, single containers, and yeah, these are the code we described before. So we have the implementation level of Kubernetes and OpenShift. Before proceeding with complexity, I just want to describe what is going to do the post container. The post container just needs to be launched in order to host some namespaces and details for the underlying containers. Just a little example. I'm going to run some little containers. I'm going to spin up Nginx, another Nginx, and so on. If we are going to see the IP address of this container, we can see that we got this nice IP address. And the same for the second one. But what happens if we are going to shut down this container and start another one? Obviously, the IP address is going also to change. And that could be a bad idea. I mean, if we have a huge compute node with a lot of containers, and our application is going to crash. What happens? Our application needs a new IP address, and it means a reload of IP tables. So with the post container, we are attaching our application to the post container using the same namespace, the network namespace. Obviously, you can use also other namespaces, and we are going to see that. So it's time to add a little complexity, and also it's demo time, and I hope to don't get the same result of Homer, by the way, of The Simpsons. So we got our implementation in Kubernetes, and we can start our own pod directly from Docker. So for the sake of simplicity, I'm just copying and pasting. Just let me remove the running containers. It's quite slow, sorry. So what I'm doing right now, I'm just starting a Docker container in detached mode, removing after its exit, name it ContainerDays, using the Kubernetes registry image pose. Let's wait. We should see as soon as possible. Yeah, it's there. So we are also to create a pod made of 2 containers. And just take a look what I'm declaring. I'm using some arguments of the Docker run instruction that honestly I never used before Kubernetes, and we are using them without knowing that what's happening in the background. So we are specifying the network to use the network namespace provided by the container named ContainerDays. Then we are also setting some limitation regarding the CPU, and I missed probably also memory. Oh my gosh, yeah, I missed memory, sorry. But we are also setting our requests and our limits. Okay, as you can see, we got our Nginx running, and we need also to attach a new container. I just decided to use foo bar, but under the hoods, it's simply Redis and Nginx. So, as you can see, we got 3 containers running, and how we can ensure that these containers are sharing some stuff? Well, we can use netcat. So, I'm trying to access the container F, the Redis one. Yeah, I'm inside. So I'm using netcat just for testing if a port is reachable or not. And I'm going to use the localhost, and Redis port is 6379. Yeah, it's open. So, as you can see, we got also an Nginx running in a sort of a pod. So I'm expecting that also the port 80 is open. In fact, they are sharing the same network namespace. I can do the second check, assessing right now the Nginx container. So we are going to do the same. Yeah, it's open. Yeah, it's open. So, ladies and gentlemen, we got a pod, and this is the magic of Kubernetes. No, sorry, this is another joke. By the way, as I said before, we got something missing. Memory request. I also forgot to set the memory limit, by the way, but it's not so crucial. Memory request is primarily useful to the scheduler. So when we are going to set up a pod to an host, and so it's not declared at Docker level or the container runtime implementation. And also about security context. I used a lot security context, and to be honest, mostly on OpenShift container platform, and its name were security context constraints, because OpenShift is a platform as a service built on top of Kubernetes. By the way, with Kubernetes, you can set some limitation. You can force to use a specific user or a specific group, and you just need to set these options. So the user, group add, the capabilities add or drop to run the container in privileged mode, the security options for AppArmor or Linux or whatever. So it's nothing so critical. By the way, this is just a little implementation of a pod with Docker. So let's go with more complexity, since we are all involved with containers and we love complexity, just joking. So the complexity is going to be brought by systemd, another joke, sorry, because with systemd we can do everything, and systemd is everywhere. I'm sorry, I really love systemd, but sometimes it's quite tricky to me. Also because I'm not a sysadmin, or yeah, I'm also a sysadmin, but I'm formerly a developer, and sometimes I see some inconsistency. By the way, I'm not to argue against systemd. It's awesome, sorry. So, I wrote down this little systemd unit, and I decided to name it edamame. Who knows what is edamame? Yeah, they are really tasty. I got my 2 daughters, 4 years old, and they are going crazy when we go to the Japanese, because they are asking, edamame, edamame. So I decided to write my little orchestrator of containers, and I will name it edamame. So, edamame pod, awesome and tasty pod. It's quite easy, and as you can see, I'm also using the xxstart pre. And right now, I'm going to echoing something, and then creating a volume. So, how many people ever use the init containers? This is how Italians raise hands. Yeah? So, I use the init containers a lot because they are really useful and are widely used also on container patterns, and I will talk about later. So, right now, I just left this empty echo that could be init script, and then I created also a volume. Why this? Because sometimes when we are starting a pod with 2 or more containers, we are going also to use a shared volume, a shared folder between the containers. So right now, I'm just using the Docker implementation just for the sake of simplicity. But after this press start, I'm also starting my container. In this case, I'm starting the pause container. And when we are going to stop it, we just need to stop edamame. Why I'm not also removing that? Because I'm already using this option. So when the container is stopped, is automatically removed. And as you can see, I'm using also the restart always. So if you want to get rid of Kubernetes, maybe it's a really bad idea, you can just set some if-else conditions down here. So you can set restart always, once, and so on. So this is the pause container. Let's see also the unit for the foo service. The foo service, also known as Redis. I really love Redis, by the way. And as you can see, it's nothing so special. Right now, I'm just running the container, naming it edamame foo, attaching the volume and mounting on etc edamame, and I'm also using the network flag of the Docker run instruction, and the same is also for the edamame bar service. Right now, I'm going just to show you how it works. I don't know. It's quite shy, the Docker daemon right now. I don't know. Yeah, here it is. So, the system. I don't remember the name. Okay, I just copy and pasted the content of the unit, and I'm going to show them just to prove them. So, since I'm not sure, I'm going also to reload the daemon. And let's see if we got our running container. Well, it's loaded, but inactive. It's dead. So I'm going to start it right now. Systemctl start, itamame, and pod. I just launched the systemd unit, and I hope to get the result as expected and don't get finished like Homer. But what the heck is happening? Ooh, it's running. Oh, yeah. The rise of containers. As you can see, this option, well, this strategy to run containers is not so optimal. It's just a proof of concept on how to build your container orchestrator. By the way, you don't need a container orchestrator, you just need Kubernetes. So, I'm going also to skip the proof of concept that the containers are communicating each one. So, in the introduction of my talk, I talked about the container patterns because I'm a developer, and as a developer, I see I see patterns everywhere. I wake up in the morning and I see a pattern. So, where are container patterns? Yeah, this is the good book I read, and I strongly suggest it's by Brendan Barnes, and it's quite useful. And yeah, I bought the the book, and right now it's free and can be downloaded in a PDF version. And I want to share with you my little implementation, and I'm sorry, this is just a little selfless promotion, by the way, but I'm going to show how container patterns and the ambassador one could be really, really nice. So, I just need to give you a little context. I was working mainly as cloud consultant in a big company in Italy, and this customer was running OpenShift and was near to the container adoption and wanted also to start to set up the metrics implementation. So when we talk about metrics, obviously we are going to talk about Grafana, Prometheus, and so on. And OpenShift is made of several Ansible playbooks to set up all the whole stuff. And also Prometheus was secured by design with a OAuth server in front of him, of it. So what happened? We needed to put a bearer token as header in the request from Grafana in order to get the data from Prometheus. So my first thought was to start re-implement the installation of Grafana. I mean, I was near to create a fork and then put some specific plugins in order to put also the authorization header. And I figured out that was the wrong way because what happens when Grafana has a new release. You have to rebase everything, maybe something is broken, and so on. The ambassador, instead, is a useful pattern because we are just using the shared namespace for the network. So I wrote down this little Go application that is just a proxy, okay? So let's just recap. Yeah, we need the token in order to interact with the Prometheus secured by OAuth. And then I also performed the proxy, as you can see here. I'm just accepting a request performed by Grafana. I'm going to decorate it with a new header, the authorization one, claiming the bearer, and then forwarding it to the Prometheus service of OpenShift. So as printf, it's quite common across the languages. So I'm just setting http://myprometheus-instance.service and so on, and then the request URI. So in the end, with Grafana, I just need to patch the deployment configuration from OpenShift. So instead of running a single container, I'm going to run two containers, the Grafana one and the Ambassador one. And when I'm going to put also to define, sorry, the the Prometheus data source, I'm going to declare the localhost and the Prometheus port in order to reach this proxy, also known as the ambassador, and then forwarding all the requests to the real Prometheus in order to skip the OAuth. Well, we are not skipping, but we are going to accept the bearer. And that's all. And if you have any question, I will be happy to answer them. And thanks for listening.